welcome back to another video, and in this video we're going to be continuing on with our macOS development with AppKit tutorial series. And in this particular tutorial we are going to be taking a look at how we can use NSHostingController, an NSViewController subclass built into SwiftUI to host a SwiftUI view hierarchy in our AppKit-based applications. Now, this view controller, as I just mentioned, is not part of AppKit. This is part of SwiftUI, and it's all part of Apple's effort to allow you to integrate bit by bit SwiftUI into your AppKit applications. They have a similar thing in UIKit called UI Hosting Controller or UI Hosting View Controller that allows you to host SwiftUI hierarchies, SwiftUI view hierarchies in your UIKit applications. All right, so let's go ahead and talk about the starter application that we have here. So to start with, I have no user interface components whatsoever in the window. It's a blank window. The configure method is empty. At the top of our view controller here, if we go into Xcode, I have a variable called det records, and this is an array of det record. Now, in this application, I want to be able to display to the user a chart displaying all current up-to-date data for the United States national debt from 1790 to 2024 by fiscal year. And so I have a JSON file downloaded from the Treasury, and I have renamed it det.json, and it's inside of my project. This data can easily be obtained as well. So you can go to the United States Treasury's website and download this data. Like I said, I downloaded it in JSON format, but you could download it in CSV and XML as well. We have two models, det and det record. So if we go into our, let's go into the det model first. So the det model is pretty simple. It's just a structure that conforms to decodable, because we're going to have to decode that JSON data. And then we have a variable called data. Now this is important because data is the top level JSON object in the JSON file. So we have to match the key exactly, which we're doing here. And then data is an array of det record objects. Just like in the JSON file, data is an array of objects. Now, a det record is again a structure, but this structure conforms to identifiable and decodable. Now, each record in the JSON file does not have an ID. I just have a constant ID that gets initialized every time a new instance of det record gets created, so that way we have a unique ID that we can loop through when we create our charts. All right. Now we have let ID equals UUID, like I mentioned. And then each record has a record date, which is a string. Now this string is going to be the date represented in year, month, day format. Now, debt outstanding AMT is what the current national debt is and in that current fiscal year. And those are the only properties that we have inside of our debt record object from the JSON. Now, in the JSON, the debt outstanding AMT in the JSON itself is in snake case, but because of the fact that we need our Swift objects to be in camel case, when we're decoding our JSON, we are setting the key decoding strategy to convert from snake case. And we'll see that when we take a look at that code. But this is also a string, the debt outstanding AMT, because in the JSON, it is also surrounded by quotes, making it a string. But when we put it into our chart, we need it to be a double. So we have a computed property for that. In var debt amount, this computed property is a double. And we're simply creating a double by using the initializer for double and putting this string inside of that initializer, which returns an optional. So we're safely unwrapping that. And then of course, if it can't for whatever reason return a double, we in the else condition for our guard, we're returning 0. And then in the event that we need to format our date, or rather we need to format our debt in like a currency format, I should say. We're doing that here inside of our debt formatted property, computed property. Now return formatter string, you can see that just converts that double to a string where it's formatted like currency. And that is our debt record model. Nothing too complicated there. Now, you might have noticed here at the top of our view controller where we're creating our debt records array, we are calling a method called load and decode on our main app bundle. So bundle.main is simply this current app's bundle. Load and decode, if we jump to its definition, this is inside of an extension on bundle that I have created, where we have 3 different methods. We have load data, where we load data from a specific resource. In this case, it's a JSON file resource in the main app bundle, and this will return an optional data object. All right. So what we're pretty much doing inside of the load data method is we are getting the URL for a specific resource with the extension of JSON. And then if we can't retrieve that URL for whatever reason, like the resource doesn't exist, we return nil. Now, if we do have a resource, we are going to create we're going to return a data object and give it the contents of the URL. So it'll load that resource and then get all of its binary data and return it. This is an option. This is a process that can throw. So we are marking it with try. And then if this if trying to get that data object fails, we also return nil. Now, the decode method goes and takes some data and decodes it into Swift objects. And this method is a generic method. So we're using generics, and then we're making sure that that generic type parameter is a decodable type. So the type has to conform to decodable. So we're telling it decode to a specific type that conforms to decodable from whatever data we give it. Now this code will look identical to the code that we used to decode responses from a third-party API over the network. And that's because decoding JSON doesn't change at all. It doesn't change at all for the circumstances. Whether you're decoding a network response or you're decoding something from a file, decoding JSON will always be the same process. And so here you can see our JSON decoder where we are setting our key decoding strategy to convert from snake case. That way it can properly map between our snake case and our camel case. We're trying to decode everything. If that fails, we return nil. And then we have load and decode. This method will call both the load data and decode methods, where we're first getting the data from our resource. If that succeeds, we then move on to decoding our data to an object or objects. If either one of these is unable to succeed, inside of our else condition for our guard, we simply return nil. Otherwise, we return the objects we decoded. And that's it. Right? That's our bundle extension. And now, the last thing I want to take a look at with you is the SwiftUI view that we're going to be working with. So I have a directory in my project called charts. There are 3 SwiftUI views in here. One is det chart view, and this will this view So inside of det chart view, we have a structure that conforms to view. We have what's called a state variable using the state property wrapper. This allows us to manage state with our segmented control. When this state changes, the SwiftUI view re-renders everything to account for that change. And then we have a variable called data, which is an array of det record objects. And this is important because we need this data. We need that array of data inside of our SwiftUI views to render the chart. Now, inside of our body, we have a vertical stack, which is the equivalent to a vertical NS stack view where it has spacing of 25 points between each view inside of its stack. We have a picker with a label of chart type. And then we have a selection where we pass it $chart or selected chart type. Now, when something is prefixed in SwiftUI with a $, that is what we call a binding. So we're binding to a state variable, so our view knows to watch for any state changes, and then re-render the UI as necessary. Inside of the picker's what we call a content closure, we have two text views, one that says line chart, one that says bar chart. These have what's called a modifier attached to them called tag, and this tag modifier is taking in an integer in this case, but it can be anything that conforms to hashable, where line chart is 0 and bar chart is 1. And when each value is selected, the value in our tag modifier, is used for our state variable. And then we have a picker style modifier applied to the picker to make it a segmented control. After our picker, we have a condition that if our selected chart type is 0, we're going to render a det line chart. And this line chart will take in the data that we have. And then if it's anything other than 0, we will render our det bar chart, which again takes in the data. Now, if we take a look at our det line chart, this view is relatively simple. It has no state, but it does render a chart. So we have a chart view that takes a content closure. We have what's called a for each view. Now, this will loop through the data that we give our line chart view, or our det line chart, and then render some kind of view that we give it for every iteration. In this case, we are rendering a line mark view that takes in a value and label for the x-axis and a label and value for the y-axis for each data point. And then we're setting the foreground style of the color of our line and line mark. And then we're making sure that the X and Y axes legends are visible. And so we're making sure that those axes are visible. And then we're making sure that our chart scrolls horizontally, so everything doesn't get crammed into a smaller space. Now, our det bar chart is much the same. Okay, so the det bar chart is much the same, where we have a chart inside of our body, except instead of having a bar mark inside of our for each view, we have instead of having a line mark, we have a bar mark. It takes in the X and Y as well. And then I'm also giving it a width. So we're setting a specific width for every bar in the chart to be 75. That way they don't shrink in size, and they're a little bit easier to see that way. Everything else is effectively identical, where we're setting the color of the mark. This the bars is sort of a yellow gradient instead of a green color. Then we're making sure the legend for the chart is visible, the X and Y axes are visible. We're setting the scrollable axis of our chart to the horizontal X axis, so that way we're not cramming all of our data. And that's it, right? So that is what we'll render in SwiftUI. Now comes, how then do we actually make that happen? Well, if we go into our configure method, the first thing that we need to do is we need to create an NSHostingController object. And we can do this by saying let, we'll call it hosting VC. So hosting VC equals NSHostingController. Now, the initializer for this controller takes in a root view, and this is going to be some kind of SwiftUI view. So in this case, we will give it det chart view, and then we'll pass it the data. So det records. Now, Xcode will yell at you because it can't find NSHostingController. And the reason for that is because we haven't put in an import statement for SwiftUI. So after we import Cocoa, we need import SwiftUI. Just like that. All right. And so now that we have our hosting controller, what do we do with it? Well, we need to use a concept in AppKit that also exists in UIKit called a view controller containment. Or more simply, we need to actually use our view controller as a container for this view controller. And in order to do that, we need to say add child, and then we pass it the view controller that we want to add as a child to this current view controller. And in this case, it'll be the hosting VC that we just created. Now, the next thing we need to do is we need to set up the view of this hosting VC to enable programmatic constraints, add it as a subview to this view controller's view, and then constrain the view of the hosting VC, just like we would any other view. So after we've added this hosting VC as a child view controller, we need hosting vc.view.translates auto resizing mask into constraints equals false. Hosting vc.view, and then we will surround that in parentheses and say view.add subview. There we go. And then finally, we need to constrain this view. So we'll say NS layout constraint dot activate. We'll say hosting VC dot view dot top anchor dot constraint equal to view top anchor hosting VC dot view dot leading anchor dot constraint is equal to view leading anchor hosting VC dot view dot bottom anchor dot constraint is equal to view bottom anchor. And then finally, hosting VC dot view dot trailing anchor dot constraint is equal to view trailing anchor. All right. So let's go over what we just did inside of our configure method again. So inside of our configure method, we created a NSHostingController with the root view of det chart view. We passed that view the data that we decoded from our JSON file. And then we added that hosting view controller, or that hosting controller rather, as a child view controller of this current view controller using view controller containment. Then we are making sure that the view of the hosting controller is constrained to the view of this view controller by enabling programmatic constraints, adding it as a subview, and then actually activating its constraints. All right, so with that should be everything. Let's go ahead and save it and run our code. We have a successful build. And here's our application. We can see our segmented control. And down beneath our segmented control, we have a bar chart where you can see our data. We can see all the national debt data from the most recent fiscal year to the fiscal year of 1790. Now you could reverse this using the reversed method on the array, and then making sure that it is mapped to be an array of debt record objects instead of the reversed collection. That the reversed method results in, to see everything from 1790 on up. Now, if we select bar chart, we can see the type of chart changes. So now instead of seeing a line chart, we see a bar chart. All right. So with that pretty much does it for this video on how we can embed a SwiftUI view hierarchy into a AppKit based application using NSHostingController. Thank you all so very much for watching, and we'll see you in the next video.